Hello, beta. Good evening, everyone. So, today we are going to start with section 5.4 of Devore. And, in case you need the notes for semester 2 statistics, intermediate statistics, beta, you can go ahead and download our app, which is ArthaPoint. And plus, you can just drop a message at 83686 63950 and you can ask Rohit sir to add you to the batch of stats. Right, beta? So you can go ahead and become a member of this batch and you can just drop a message on this number. You will be added to the statistics batch, and in that batch you will see all these notes that I am teaching you daily on YouTube. Okay, beta, let's start with section 5.4 today. So before we do this section, I want to go ahead and I want to just revise what we did in the last class. So if you remember, we said that first of all, the population is not always at our disposal. पूरा का पूरा population हमारे पास हमेशा नहीं होता है. And because the population is not always at our disposal, therefore we need to go ahead and we need to work with the sample. Right, beta? So suppose someone goes ahead and they actually go ahead and collect the entire data of the population. अगर कोई जाकर सही में पूरा population का data collect करना चाहता है कि अच्छा ठीक है, so for example let's say I want to go ahead and I want to research about the income of people in India. मुझे जानना है कि लोगों की on an average income कितनी है. And let's say I start going to each and every household. मैं एक एक घर जा रही हूँ across different states and I start asking them, okay, how much is your income? How much is your income? How much is your income? ऐसे करके मैं एक एक का income पूछ रही हूँ. So if I collect the data of all the people in the population, अगर मैं एक एक इंसान का जितने भी लोग पॉपुलेशन में हैं अगर मैं उन सब का डेटा कलेक्ट करूं देन बेटा बेटा दैट इज कॉल्ड एज सेंसस. उसको सेंसस बोला जाएगा. सो सेंसस इज बेसिकली अ काइंड ऑफ अ सर्वे or whatever information you require, but you go ahead and you collect the information of each and every member of the population. आप हर एक इंसान से जो भी population में है हर एक से जाके डेटा पूछ रहे हो, then that becomes a census. So a census is when you go ahead and you ask each and every individual of the population. Now, since you have collected data of the entire population, there is no reason why you will be making any kind of error, right? It will be error free. Error free in the sense, kya matlab hai beta? So imagine, suppose due to some reason, I am not able to collect the information of all the people in India. And इसका एक बहुत बड़ा reason ये हो सकता है that the population is huge and I don't have time to collect information about every individual. हर इंडिविजुअल के बारे में जानने का उसको समझने का कि उसके पास कितना इनकम है आई डोंट हैव टाइम फॉर दैट. So let's say what I do is I decide that from every state I will ask the income of say 500 people. From every state I will ask income of 500 people and that will go ahead and become my sample. Now what will happen in this case beta? क्या problem आएगा इससे? One, it will be very timely process. जल्दी जल्दी ये काम हो पाएगा because now I just have to collect data of 500 people each. But it can create some error. हाँ, suppose ये जो 500 लोगों का data मैंने collect किया, these 500 people whose data I collected, let's assume that almost all of them were either middle class or rich people. Then this data will be very biased. ये जो sample होगा ये बहुत ज़्यादा biased हो जाएगा. So when I go ahead and I collect a sample and I use the sample for taking the information, yes, it is going to be a very timely process. Comparatively आसान है करना because you're just taking data of few people, but it can go ahead and it can lead to some kind of error. कुछ ना कुछ error हो सकता है and therefore When you talk about census, that means when you go ahead and you collect information from all the people, जब आप पूरा population का बात करते हो, जब आप census से information collect करते हो, we ensure that that is error free. ये हमें guarantee हो जाता है that because I have collected data of entire population, मैंने सबको ही ले लिया है, there is no reason why I will go ahead and make an error and it will become error free. Okay. अच्छा बेटा अब आगे देखो. So we are saying that whenever we collect census information, there are two main problems that we face. The first problem is very time taking process. अब imagine करो, India has such a huge population. इस population के एक एक इंसान से data जाके collect करना is literally impossible task. It is going to be very, very time consuming. And at the same time, it is going to be a very expensive task also. क्यों expensive होगा बच्चे? Because I have to travel so many cities. I have to travel so many houses, right? There is going to be a huge opportunity cost involved also. You are an economic student. You know what is the meaning of opportunity cost. So we understand that number one, this is going to be a very time taking process. Number two, it is going to be a very expensive process. बहुत महंगा होगा, बहुत पैसा लगेगा, बहुत time भी जाएगा. So therefore, this is literally an impossible task to be done. ये करना एकदम ही impossible चीज है, right? So since I cannot go ahead and I cannot collect information related to each and every person, I cannot go for the population. Therefore, I must go ahead with the sample. So the जो best चीज है that I can go ahead and I can do is work with a sample. So what I want to do, because this is impossible, I cannot work with the census, I cannot work with the population. Therefore, I must go ahead and I must work with the sample. अब next question ये आता है, how can I go ahead and how can I collect the sample? There are multiple ways to collect the sample and you must have read about some of the ways. आपने शायद सुना होगा something called as random sampling, stratified sampling, and many other ways, हाँ, snowball sampling, etc., etc., etc. तो sample collect करने के बहुत अलग-अलग तरीके हैं. There are multiple ways to go ahead and collect the sample, but one of the easiest way of collecting sample that is known as random sampling. Now, what do we do in random sampling? So imagine something like this. Suppose I want to go ahead and I want to collect data. तो मैं क्या करूंगी ना? Say there are these 500 houses in this region. House number 1, house number 2, house number 3, and so on. House number 500. So I will create 500 chits. Chit 1, chit 2, chit 3, and so on till chit 500. And I will put it in a box. मैंने एक box के अंदर इसे रख दिया and I will just shake it. I will just spread it around. And then I will ask you कि ठीक है बेटा, मेरे को 50 houses का sample चाहिए. Start picking up chit. तो आपने पहला chit उठाया, you open up that chit, the number comes as 45. तो house number 45 will be part of my sample. फिर आपने दूसरा chit निकाला and that comes out as 387. So house number 387 will be part of my sample and so on and so forth. So in that sense, we are ensuring that this is completely random in nature. Now, in the real world, beta, we don't even have to go ahead and do this thing. हमें ये करने का भी जरूरत नहीं है. We don't have to go ahead and we don't have to do this thing. Rather, what we can go ahead and we can do is use some or the other software. So when you go ahead and you use software like R, Stata, Python, जब आप ऐसे softwares use करते हो, you ensure that you are going ahead and doing random sampling. हाँ, R में एक option होता है which is called as set seed, which helps you to go ahead and collect a random sample. ऐसे ही Stata में, Python में भी होता है which helps you to collect a random sample. So you can go ahead and you can work with random sampling. और वो random sample के लिए काम करने के लिए what is required बच्चे? You just have to use a software. और पहले के टाइम पे जब statisticians करते थे, they would go ahead and make these chits and pick up the chits to ensure that it is completely random in nature. Clear हो गई बात? Okay. नाउ क्वेश्चन ये आता है कि व्हाट इज द प्रॉब्लम व्हेन वी यूज द सैंपल। जब हम सैंपल यूज करते हैं तो प्रॉब्लम क्या आती है, व्हाट प्रॉब्लम डू वी इनकर। The first problem that we go ahead and we incur is that there are multiple ways of collecting the sample out of the population. तो जैसे बेटा मैंने आपको बुलाया, हाँ आई कॉल्ड स्टूडेंट नंबर ए, मैंने बोला अच्छा इसमें से बेटा 50 हाउसेस का सैंपल कलेक्ट करो। तो शायद आपके 50 हाउसेस होंगे, हाउस नंबर 45, हाउस नंबर 387, हाउस नंबर 500 एंड सो ऑन। बट सपोज आई गो ahead and I ask स्टूडेंट नंबर बी कि बेटा कलेक्ट इसमें से 50 चिट्स निकालो एंड गिव मी अ सैंपल। Maybe the chits he has picked up is house number 1, house number 7, house number 28 and so on. So the sample that you have created will be different from the sample that person number B will create. It will be different from the sample that person number C will create. तो हर individual एक अलग sample create करेगा. And since each individual will go ahead and each individual will collect a separate sample, they will collect a different sample. Therefore, the answers that I will get from the sample will be very different. मतलब शायद ऐसा हो सकता है कि जो इंडिविजुअल नंबर ए ने सैंपल कलेक्ट किया हो 50 ऑब्जर्वेशंस का, when I go ahead and I find the mean of this 50 observation, maybe I observe that the mean comes out to be 402. Average income comes out to be 402. But when I ask individual B and he picks up 50 chits out of the sample, so the average income comes out to be 450. So it is possible that because they have collected different samples, the average that they will be getting will be very, very different. And this is exactly beta what we studied in the last section, 5.3. So if you remember, when I did that example, जो हमने कल एक example किया था, which talked about 2 GB, 4 GB and 8 GB RAM, and which talked about their revenues, तो उसमें हमने दिखाया था कि how from sample to sample the average was differing. Average could have been 80, average could have been 90, average could have been 100 and so on. So the average actually differed. So we showed how from sample to sample the average mean can differ. Now, if you remember, we had gone ahead and we had called the mean value as the statistic, right? The mean value of the sample, it was called as statistic. And our aim was to go ahead and to see that this is as close to the value of the population parameter. और अगर आपको याद हो तो इन द एग्जाम्पल दैट वी हैड डन एज पार्ट ऑफ सेक्शन 5.3 हमने ये एक्चुअली बात शो की थी कि जब हम मीन का मीन निकालते हैं, व्हेन वी गो अहेड एंड वी फाइंड द मीन ऑफ द मीन, इट वाज कमिंग इक्वल टू द मीन ऑफ द population. Better please go ahead and look into that video and come, it will be very useful, because yesterday we have proved this in an example that the mean of the mean was coming equal to the mean of the population. Similarly, we had actually gone ahead and proved that when we go ahead and find the expected value of the variance of the sample, it was coming equal to the variance of the population. Am I right? So try to understand from here. I am saying that when whatever samples we have picked up, तो if you remember, हमने बोला था कि ठीक है हमारे 9 सैंपल निकल रहे थे. I will just take you quickly to that example. So this was the question which we had done. This was the question that I had gone ahead and I had taken. This one, huh? You remember, this is the question we had gone ahead and taken. And I had shown you that these were the 9 samples that we had. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or depending on what sample we had collected, जो भी हमने sample collect किया था, based on the sample we had collected, we were getting the sample mean. So the sample mean differed. The sample mean was not equal to the population mean. हमारा जो population mean था वो अलग था, and sample mean were very, very different. But what we proved is that if I go ahead and I find the mean of these sample means, if I sum up all these sample means and divide it by the number that we have, if I go ahead and I find the mean of the sample mean, in this case, इनका एक probability distribution बना था like this. So when we go ahead and we find the mean of the sample mean, so we had actually found out that it was equal to the mean of the population. वो population के mean के बराबर था. This is what we had gone ahead and we had found out. You remember that from the last section? Okay. Now we will come back to what we were doing here. So basically what we have therefore is that हर sample का जो statistic होगा उसका value अलग होगा, right? And हमारा aim ये है कि जब भी हम कोई भी sample pick up करें, it should be as close to the population as possible. उस sample से जो भी हमें answer मिले, it should be close to the population. It would be a good estimate of the population. Okay, बेटा. अब हम बात करते हैं सेंट्रल लिमिट थ्योरम का. लेट अस टॉक अबाउट CLT. So now try to go ahead and try to understand that when we talk about the central limit theorem, what it is saying. Let x1, x2 and xn be the random sample from a distribution with mean mu. तो हमने क्या किया है ना, हमने एक पॉपुलेशन ली है, इसको बार बार दूसरे जो हमने कल एग्जाम्पल किया है, ट्राई टू कंपेयर इट विद दैट एग्जाम्पल. तो उस एग्जाम्पल में द मीन ऑफ द पॉपुलेशन वाज 106. फिर हमने इस पॉपुलेशन से सैंपल बनाए थे, तो हमारे पास 9 सैंपल्स क्रिएट हुए थे. सैंपल 1, सैंपल 2 एंड सो ऑन टिल सैंपल 9. वी वर एबल टू क्रिएट 9 सैंपल्स. अब हम कह रहे हैं लेट x1, x2 टिल xn बी रैंडम सैंपल फ्रॉम दीज डिस्ट्रीब्यूशन. तो ये हमारे अलग अलग सैंपल क्रिएट हुए थे. According to the last example that we did in the last lecture, there were 9 samples that were created. ठीक है. और पॉपुलेशन का मीन जो है वो 106 था और पॉपुलेशन का वेरिएंस सिग्मा स्क्वायर है. इफ n is sufficiently large then x bar approximately is normally distributed. तो अगर ये जो सैंपल है ये बहुत लार्ज सैंपल है, इफ द साइज ऑफ द सैंपल इज लार्ज इनफ, तो हम ये कह रहे हैं दैट द सैंपल विल बी अप्रोक्सीमेटली नॉर्मली डिस्ट्रीब्यूटेड. हम एज्यूम कर सकते हैं दैट इट विल बी नॉर्मली डिस्ट्रीब्यूटेड. एंड इन पर्टिकुलरली क्या नॉर्मली डिस्ट्रीब्यूटेड होगा, अगर हम इन सैंपल की मीन वैल्यू निकालते हैं. इफ आई फाइंड आउट द मीन वैल्यू ऑफ दीज सैंपल्स और उसको मैं प्लॉट करती हूं, इट विल बी नॉर्मली distributed. Am I clear with this, बेटा? तो ध्यान से वापस एक बार ही देखो. The central limit theorem is of utmost importance and it is one of the most important thing that we have to understand in statistics. So try to understand this thing. We are saying I have a population. From this population, I want to create a sample. There can be many samples that can be created. So from this population, I can take sample 1. So suppose example, I have a population of 500 and I need to take a sample of 50. So I can take this in many ways. I can create sample 2, I can create sample 3, I can create sample 4 and so on and so forth. Each of them has 50 observations. Now I am saying that I am finding the mean of sample 1, I am finding the mean of sample 2, mean of sample 3, mean of sample 4 and so on. Now I am saying, of course, from the last example, you will remember कि ये जितने भी हमारे पास mean आ रहे थे, I can go ahead and I can create a probability distribution out of these means. इन means का ना हम एक probability distribution बना सकते हैं कि अच्छा अगर mean 80 है तो इसका corresponding probability कितना, अगर mean 90 है तो इसका probability कितना, अगर mean 100 है तो इसका probability कितना, 110 है तो probability कितना and so on and so forth. So I can go ahead and I can create a probability distribution associated with these. मैंने इससे related एक probability distribution बना दिया. Now I am saying that if the sample size is large enough, अगर जो हमने ये sample निकाले थे, if these sample size is large enough, I will tell you what large enough means. कितना large हम उसको मान सकते हैं. We will talk about that. But as of now, I am going ahead and saying that if the sample size is large enough, then if I go ahead and I try to plot this x bar, अगर मैं इस x bar को plot करने की कोशिश करूं, then this x bar will come out to be approximately normally distributed. इसका जो distribution बन के आएगा, it would be approximately normally distributed. So let us try to read this out, beta. I am saying if n is large enough, then x bar is approximately normally distributed. Actually ये वाला बात तो हमने कल ही प्रूव कर दिया था, even with small sample, that I had already proved this in the last lecture, that if I try to find out the mean of these x bars, then I will get the mean of the population, right? So this is what this is saying. If you find the mean of these x bars, you will get the mean of the population. And in fact, the other thing also we proved that if I find out the expected value of the variance, right, then I will get the expected value, I will get the variance of the population. But this has been written in another way, that if you go ahead and you find out the variance of this x bar, this is another thing you have to remember, then it will be equal to the variance of the population divided by n. Variance of the population divided by n. तो ध्यान से हम एक बार सेंट्रल लिमिट थ्योरम को समझ लेते हैं. The central limit theorem goes ahead and says you have a very big population. उस population से आपने अलग अलग sample निकाले, उन samples का आपने mean निकाला. अगर जो भी अलग अलग sample निकाले हैं, when you find the mean of each of the sample, अगर इन mean का दोबारा आप mean निकालोगे, अगर आप इन mean का mean निकालोगे, it will be equal to the mean of the population. और अगर आप इन mean का variance निकालोगे, it will be equal to the variance of population divided by n. This is what the central limit theorem is saying. Am I clear with it? Okay, beta. अब बहुत ही interesting portion है. Let's try to continue this. So this says, and T naught has approximately normal distribution with this and this. अच्छा एक बात बताओ. But I have told you that the mean of x bar is equal to mean of the population. Mean of x bar माने क्या? When you sum all x bar and divide by n, it is equal to the mean of the population. It means that all the summation of x bar should be equal to the mean of population into n. Beta, this means the sum of x bar, that means the totals. So I can go ahead and say that the total, it is having the value as n mu. It is having the value as n into mu. Ye dekho yahan pe, come back here. So we are saying that if I find the mean of the totals, that means if I go ahead and I sum these totals around, then it will be equal to n into mu. So the mean of the totals will be equal to n into mu, and the variance of the totals will be equal to n sigma square. अब क्वेश्चन ये है कि कितना बड़ा n होना चाहिए, how big the n should be. So the rule of thumb is that as long as my n is greater than equal to 30, तो the central limit theorem will hold true. तब तक CLT hold true करेगा. Okay, beta. Now let us try to go ahead and revisit the concept once. It is a very, very important concept. जितनी बारी देखोगे उतनी बारी कम है. So we are saying that क्या कह रहे हैं हम, that if I have a population and I pick up a sample from this population, मैंने इस population से अलग अलग sample निकाले, sample 1, sample 2 and so on till sample n, और हर sample का मैंने mean निकाला. Then if I find the mean of these means, then it will be equal to the mean of the population. And if I find the variance of these means, then it will be equal to variance of population divided by n. Acha, now, beta, if I just ask you what will be the standard deviation of the mean, so how do we find the standard deviation? We give the under root of the variance. So this is going to be under root of sigma square by n, and this is going to go ahead and give you sigma by root n. Beta, this value that you have got here, इसको हम standard error भी बोलते हैं. This value is also called as the standard error. This value is also called as the standard error. अब error क्यों? Why error? Because if you remember, then we have said that whenever you collect a sample, you can commit some kind of error. जब भी आप कोई भी sample collect करते हो, आप किसी ना किसी तरीके का error कर सकते हो. Why? Because the sample will deviate from the population. Just take another example. तो जैसे अगर मैं बोलूं कि population is of 500 people who are telling me whether they voted for party A or party B, political party A or political party B, and I create a sample of 50 people, तो बेटा यहाँ पे जो भी मेरा result आएगा, suppose this 50 people, 40% say they voted for A and 60% say they voted for B. तो in reality, when the actual results will come out, maybe it will be the case that actually 50% had voted for A and 50% had voted for B. So the sample that you have collected, there may be some error that you might have committed. सैंपल में जो भी आपका इंफॉर्मेशन आ रहा है, whatever answer you are getting, it is going to be close to population, but it will not be exactly equal to population. There will be some error that you will be committing, and that error becomes the standard error. So the formula for standard error is basically called as sigma by root n. It is called as sigma by root n. Am I clear with that? Okay, beta. So this is also known as the standard error of the sample mean. And why I am committing error, I have also cleared this out. Okay. Next thing that we want to go ahead and focus on is that as the sample size increases, जैसे जैसे n का value बढ़ेगा, as the sample size increases, you will be going towards closer and closer normal distribution. अब इसको समझने के लिए we can go ahead and refer to this diagram here. So if you go ahead and you notice, beta, this is your population distribution. This is how population is distributed, right? And what we are saying is that this is your sample size for small sample n. So this is, for the population, the mean value is this. ये आपका mean value है. ठीक है? This is for a smaller to moderate n, small values of n, maybe n का value 10, 15, 20 रहा होगा. And this is for larger values of n. यहाँ पे n is large. Now you need to go ahead and you need to notice that as the size of the sample is increasing, देखो यहाँ पे the size of the sample is small. तो जब sample size small है, we go ahead and we realize कि हमारा sample के mean से deviation है, population mean से deviation है. This is my population mean, which is mu. और sample mean average यहाँ आ रहा है, where it takes a peak. Right, where it takes a peak. Now you need to realize that as my sample size is increasing, तो ये जो distribution है, it gets centered around the population mean. It gets centered around the population mean. So it becomes a better approximation of population mean. So as your sample size increases, we can go ahead and we can say that it becomes a better approximation of the population means. It becomes more closely concentrated around the population mean. ज़्यादा population mean के पास होना शुरू हो गया है. Also, it becomes more and more normally distributed. Okay, so now we have also talked about T naught. T naught refers the total of the observation, and it is also approximately normally distributed. Here you have n mu, and here you have n sigma square. Okay, so we have talked about this also. The larger the n, the better the approximation. Okay, beta. Now we need to go ahead and take this example. So here, example number 5.26. Please read this example. It says the amount of particular impurity in a batch with chemical has mean value 4 gram. So you are given that the mean of the population is 4. And it says that the standard deviation of the population is 1.5 and the size is 50. So मैंने आपको बोला that central limit theorem holds well if the sample size is greater than or equal to 30. And here, since the size is 50, so we know that the central limit theorem will hold pretty well. Okay. Are independently prepared, what is the probability that the sample average amount X bar is between 3.5 and 3.8 gram? So the question is, we need to find out what is the probability that X bar is between 3.5 and 3.8. अब मेरी बात बहुत ध्यान से सुनना. Because n is greater than 30, we will write this line. So because n is greater than 30, the central limit theorem holds true. And since the central limit theorem holds true, we can say that X bar is approximately normally distributed. And since x bar is approximately normally distributed, what can we do, bache? We can go ahead and we can convert this in the form of a z variable, in the form of a standard normal variable. We can convert this in the form of a standard normal variable. And how do we convert this in the form of a standard normal variable? Very simple. It will be x bar minus mu upon standard error of x bar, or standard deviation of x bar, as you may say. So x bar minus mu upon its standard deviation was sigma by root n. Its standard deviation was sigma by root n. So let us try to go ahead and let us try to convert this now. So if I just try to convert this beta, I will get 3.5 minus mu upon sigma by root n less than x bar less than 3.8 minus mu upon sigma by root n. Am I clear? You are already given that mu is 4. You are given that sigma is 1.5. So sigma by root n, but that will be 1.5 divided by root 50. And this is going to be 0.2121. This will be 0.2121. So now I just need to go ahead and I need to plug these values here. So you're given that mu is 4. I've plugged 4 here. Sigma I have plugged here 1.5. And root n, that means I've plugged the value here. Right? Now, when you will solve this, you will get this. But we know this is normally distributed. So I can get the values from the normal table. I can always go back to the table and I can get the values. We have already studied how to read a Z table, isn't it? So if I just go ahead and look here, beta, हमने CDF, PDF पढ़ा है. अब यहाँ पे देखो, if I just want to go ahead and I want to shade this region, so this is minus 2.36, I have written it here. And this is minus 0.94, I have written it here. And I want this region. I want to calculate this probability. Isn't it? So if you go ahead and you really look into it, you will understand that if I take 0 here, and I take minus 0.94 here and minus 2.36 here, at any point of time, I can go ahead and I can find out this region first. This region. Isn't it? At any point of time, I can go ahead and I can find out this region. So I can call this as the cumulative distribution till 0.94. So you go to the Z table, you find out ki minus 0.94 kahan pe aa raha hai, and you find out the corresponding probability. Minus, you find out this region. Minus, you find out where minus 2.36 is coming. So when you will be subtracting that 2, you will be able to get this region. Right? So I hope all of you know how to read the Z table. If not, just tell me. I will post a video on that. But you should know how to read the Z table. So from there, you will be able to get the answer. But the question here is, why were we able to go ahead and use the Z table in the first go? We were able to go ahead and we were able to use the Z table because we could use the central limit theorem and we could go ahead and say that it is actually normally distributed, right? Okay, beta, take this example now. This is very interesting example. So example 5.27 of Devore, try to read it out. So what it is saying is that let X be the number of defects. And the mean of the population is given as 3.2 and the sigma is given to you as 2.4. And you're given that the sample size is 100, right? And it is asking what is the probability that the mean will be more than 4. Now, why this question is interesting in this case is that beta, try to understand that we are talking about the number of defects. And number of defects जो होते हैं, it is actually a discrete variable. ये एक normal variable तो ये एक continuous variable तो है नहीं, it's a discrete variable. And when I talk about normal distribution, तो normal distribution तो actually continuous variable के लिए काम करना चाहिए. But the exciting part here is that because n is large enough, क्योंकि n का size 30 से बड़ा है, because n is large enough, and I am talking about the distribution of the mean values, we can go ahead and say that it will be normally distributed. Even though x is representing discrete variable, x एक discrete variable को represent कर रहा है, even though x represents a discrete variable, I am able to go ahead and use a normal distribution on it using the central limit theorem, because I am talking about distribution of the mean, first thing, and secondly I am talking about sample size greater than 30. ठीक है बेटा. So now I want to go ahead and I want to find out what is the probability that the mean is more than 4. So what can you go ahead and do? Again, because central limit theorem can be applied, you will convert this in standard normal variable. So minus mu upon sigma by root n greater than 4 minus mu upon sigma by root n. You can go ahead and put the values. So sigma का value आपको already given है बेटा. Your given sigma is 4. X bar आपको check करना है at 4. So this is Z value. So this will be probability Z greater than 4 minus mean दिया हुआ है 3.2, sigma दिया हुआ है 2.4 divided by root 100. So when you will go ahead and find this value, you will get this value as 3.33. फिर से एक बारी अगर हम टेबल की तरफ जाएं, if I just try to make a diagram out of it, so I need to find out, this is my 0, यहाँ पे कहीं पे 3.33 होगा. I need to find out this region. I need to find out this region. But isn't this 1 minus? Because I know that total will be 1. So out of 1, if I subtract this region, I will get this region. So this is nothing but 1 minus probability Z less than equal to 3.33. Right? So this is nothing but this is 1 minus cumulative distribution of 3.33. This is going to be this. Again, but this value you can find from the Z table. Z table पे जाके ये value you can easily find it out. So once you find this value, you will be able to go ahead and get the answer for this one. I think the Z value came out to be, after this, the answer came out to be 0.0004. Okay. So now, this is another thing which we should be highlighting here, which I've already highlighted, that the central limit theorem only works well if your sample size is greater than 30. But one last thing that I want to discuss today is the other application of the central limit theorem. तो एक बारी हम ये भी देख लेते हैं कि central limit theorem का और कहाँ पे application होने वाला है. तो इसमें ऐसा कुछ एक एग्जाम्पल देखो कि सपोज आई एज्यूम दैट x इज अ बाइनोमियल वेरिएबल. तो बाइनोमियल वेरिएबल जस्ट टेक्स टू वैल्यू, ईदर सक्सेस और फेलियर. तो x जैसे x कैन रिप्रेजेंट द नंबर ऑफ हेड्स व्हेन n coins are tossed. तो getting a head can be represented as success and getting a tail can be represented as a failure. So whenever we talk about a binomial variable, उसमें success and failure दो चीजें होती हैं. So what I have done is let x1 go ahead and represent, x1 represents 1 if success and 0 if failure. तो हमने ऐसा कुछ represent कर दिया कि when the first coin is tossed, जब हमने पहला coin toss किया, so it will be x1 will take the value 1 if I get head in it, and x1 will take the value 0 if I get tail in it. Then I toss the second coin, so x2 will get the value 1 if I get head in it, and x2 will get the value 0 if I get tail in it. So ऐसे करके we have gone ahead and we have created x1, x2, x3 so on till xn. हमने x1 to xn को generate कर दिया है. Now what we go ahead and we say is that xi's are identically and independently distributed. तो क्यों identical है? क्योंकि हर एक में probability head आने का भी half है और tail आने का भी half है. So they have similar distribution. And why they are independent? क्योंकि पहले coin में head आया, it has got nothing to do with second coin में head आएगा या tail आएगा. So they are identically and independently distributed. Now in this case, बच्चे, the central limit theorem goes ahead and says that if n is large enough, अगर हमारा sample size large enough है, if n is large enough, then in that case, summation xi's and mean of xi will be normally distributed. तो ये जो हमारे एक्सरसाइज हैं, हर एक्सरसाइज एक इवेंट था कि हेड आ रहा है या टेल आ रहा है. अगर हम इन एक्सरसाइज का सम निकालते हैं या मीन निकालते हैं, then they will be normally distributed. So this is one of the applications of central limit theorem. Now there are some conditions for the binomial distribution to be normally distributed. So the condition is that we want that the probability should be close to half. It should be close to 0.5. माने I don't want it to be very skewed. इतना चलेगा कि ठीक है, probability of success is 0.55 and probability of failure is 0.45. That is fine. इतना skewness चलेगा. But I don't want कि probability of success is 0.90 and probability of failure is 0.10. If this is the case, probability of success, failure, if this is the case, then I cannot say that the summation of xi will be normally distributed. ये हम नहीं बोल सकते हैं. But if this is the case, then we can go ahead and say that xi's will be, summation of xi's will be normally distributed. The condition for binomial distribution to be normally distributed is when the p's are close to 0.5 and when you have n into p greater than 10. Beta, इसी को rewrite करके we can also say that n into 1 minus p, that means n into q should also be greater than equal to 10. तो अगर ये दो condition हमारा satisfied होता है, if we have p close enough to 0.5 and np greater than equal to 10, then we can go ahead and say that in such a case, the binomial distribution follows central limit theorem. Okay, this is the last proposition of section 5.4. So this proposition ko ek bari we can go ahead and we can study. Let x1, x2 till xn be random sample from distribution with positive value. Probability of each xi greater than 0 is 1. Then if n is sufficiently large, then the product xi is approximately log normal distributed. This is just for your extra information. कि अगर हम एक वेरिएबल क्रिएट करते हैं y और हम सम नहीं कर रहे हैं, हम मीन भी नहीं निकाल रहे हैं, rather हम प्रोडक्ट निकाल रहे हैं, we are finding the product, then this product, it would be log normally distributed. It would be log normally distributed. So if I go ahead and I find the mean, then it is normally distributed. If I find the sum of xi's, it is normally distributed. But if I go ahead and I find the product of these xi's, then the product will be log normally distributed. Right, beta? Okay, so with this, we finish section 5.4.